Hey guys, and welcome back to another video on the channel. In today's video we're going to be looking at the chemistry multiple choice paper 1 for 2020. Okay, so this is for the QCAA syllabus. So with this one here you're given 20 multiple choice questions from unit 3 and 4. You're also given a data booklet as well, which includes the periodic table and a couple of constants as well. Now the reason I've got this open is because one of the diagrams in the test isn't supported online. So you actually have to follow this link to get the diagram for one of the questions. So that's why this browser is open. Okay. Anyway, each question's worth 1 mark, and yeah, let's just get straight into it. Okay, so question 1 here. So a partially filled water bottle is sealed and left on a bench in a room with a constant temperature. Okay. After several minutes, it is noted that the water level in the bottle remains constant. In the water bottle, the rate of evaporation is, and you're given a couple options. Okay. So here, we got to understand what's happening here. So if you leave water in a container, regardless what's going to happen, stuff is going to evaporate, okay? So your liquid is going to turn from a liquid to a gas, slowly but surely over time. Now, however, it's noted in this particular situation, the water level remains constant. Now, it's a sealed bottle, so it's a closed system. So what that means is the rate of it evaporating must be equal to the rate of its condensation. So condensation pretty much means from gas back to liquid. Okay. Because the reason why they're equal is because there is no change in the water level. So the rate at which it's evaporating must be equal to the rate at which it's of the condensation, because there is no change in the level. However, it won't be equal to 0. So here we've got these two options: less than the rate of condensation, greater than the rate of condensation. These ones are incorrect. Now these ones are exactly the same except for this last bit. They have equal to 0 and not equal to 0. So the reason why it's not equal to 0 is because evaporation will always occur. Okay, so if it's equal to 0, that means there is no rate, pretty much, because if the rates are equal and it's equal to 0, then virtually nothing's happening. But we know something is happening because water will evaporate. Okay, so it is not equal to 0. So this one is also incorrect. So the correct answer here is D. Okay, and that's the answer to that first one. With any questions from this test, leave something in the comments and I'll try my best to answer it, okay? Alright, let's go on to the next one. So question 2. So magnesium plus silver produces this stuff here, okay? Determine which of the following statements is true for the chemical reactions. So from a general look, this is an oxidation and reduction question. So oxidation means loss of electrons. Reduction, that's how you spell reduction, that's a C, is the gain of electrons. So if you want to think of it like reduction is reduction in charge, because if you gain an electron, your charge becomes more negative. So here we can see that the magnesium has gone from a neutral charge to a positive charge, and the silver's gone from a positive to a neutral charge. So the magnesium has lost electrons, okay? So it's lost electrons, okay? The silver has gained electrons because it's gone from a positive to a neutral charge, meaning a negative charge was added, okay? Now, so we know, alright, so magnesium undergoes oxidation. Now, if something undergoes oxidation, that means it's the reducing agent, because you're causing the other thing to undergo reduction. That's what reducing agent means. And silver is undergoing reduction, which means it's the oxidizing agent. Okay, so we just got to read these guys here and just see which one of these matches the information here. Silver ions are reduced, so that's correct there, and act as the reducing agent. So this last bit's incorrect, so this whole thing is incorrect, okay? So the first part here was correct, but they put that bit at the back which is incorrect, so that thing's incorrect. Silver ions are oxidized, that's incorrect straight away, and that's incorrect, okay? Magnesium atoms are reduced, that's incorrect. Magnesium atoms are oxidized, yep, and act as the reducing agent. So question D is the correct one, okay? Because they put it as oxidization and they've put the correct terminology here. It's a reducing agent, okay? Because it's the opposite. Alright, question 3. The general chemical equation represents the following type of reaction, and we're given a couple examples. So we've got addition, hydrolysis, esterification, and condensation, okay? So straight away, it's not hydrolysis, and it's not condensation, okay? it's not esterification either, because there is no carboxylic acid present in this equation here, okay? The reason why I know it's addition is because addition typically happens where you have a double bond and you break it into a single bond. Because notice here this chemical structure, W, X, Y, and Z could represent any functional group, but they've mainly highlighted the double bond and the single bond. It's gone from a double to a single bond, meaning there's an addition there, okay? So I would say the correct answer is the addition, okay? It's not esterification because no carboxylic acid, and there's no OH present as well, okay? Alright, question 4. Oil of wintergreen is a chemical compound with the following chemical structure. Okay, so we can see we've got benzene, and we have what's that, ester and an alcohol present. Okay, identify the functional groups present in the olive of wintergreen. Okay, so straight away there's an alcohol. Now an alcohol is the OH group. Now the ester is this guy here. Now that's hard to spot. Okay. Now remember, an ester looks like this, okay? You could have something here, so R, then you have C, double bond with oxygen, oxygen, and then another functional group. That is that structure right there, because remember, that's a carbon. That's how we draw these things, okay? So each of these represents carbon, okay? So here, that's the carbon, that's the double bond, and then that's the other oxygen, and then we've got the CH3 there. So that's a, oh, I forgot what the name was off the top of my head. It'll come to me later. But anyway, that's how you answer that first one. So the correct answer here is going to be A, an alcohol and ester, okay? Some common answers would be a carboxylic acid, but that's not a carboxylic acid. That's an ester, okay? Alright, question 5. The equilibrium constants of 4 different reactions are given. In which reaction does the equilibrium lie furthest to the left? So we need to understand what these actual numbers mean. So furthest to the left. What that means is, oh, let me just rub this out. Furthest to the left means there is the most reactants, okay? So most reactants, okay? Reactants. Now we know the equilibrium constant is your product's concentration divided by your reactants, okay? And that's a constant, okay? So if we want to work out which one lies furthest to the left, aka has the most reactants, we want this to be very significant. So if that's significantly more larger than the products, then your Kc is going to be small. So if we find the one with the smallest equilibrium constant, then we've found pretty much which one has the most reactants, hence the equilibrium that lies furthest to the left, okay? So straight away, this one is not correct. That's the biggest one, okay? Now here, remember the index remembers the number of decimals. So while this number is bigger than that, this one is smaller than that because of that thing there. So it's between, straight away, B and D. Now the reason why the correct answer is B is because, well, 3 is smaller than 6.3. So if you were to pretty much get rid of this thing at the back and you compare just those numbers, 3 is smaller than 6.3. So the correct answer here is B. So there would be significantly more of this than this stuff here. Now, with this one here, just notice that's a solid. So I don't know if you can actually include that in the equilibrium constant, but I think in this case you can. I'm going to say it's B, but usually you don't include the solid. Oh, that's why they've put the question like this. Okay. I think the answer is B still, but usually you don't have the solid inside the Kc. If someone wants to correct me in the comments, please let me know. I'll check the answers after this video, but I'll continue on with this. Okay. Question 6. I'm 90% certain it's B, but that solid thing just throw me off a little bit. Alright, question 6. Calculate the cell potential produced by this. And it's given pretty much in a cell equation, okay? So straight away, this is oxidation reduction. So if you look at your chemistry formula sheet, you get given a lot of different equations for each of the standard oxidation reduction, okay? Now, on this formula sheet, they've designed it so the strongest things that undergo oxidation, so oxidation's at the top. These are the things that are most likely to lose their electrons, okay? And then on the bottom we have the things that undergo reduction the most, okay? So the things that gain the electrons. And how do I know this? because we have fluorine on the bottom. Okay, the F. Okay, and you also have chlorine down here. Now, chlorine and fluorine are those things that just rip electrons off quite easily. And these ones here lose it, so like sodium here, etc. Okay, so straight away, the two ones we want to look at is zinc and copper. Now, there's a couple for copper. Now, if you go back to that one there, I think zinc is right there, and you want the copper where it only has the solid and the 2+, so it loses 2 electrons. So you don't want to use this one. You want to use, not that one, you want to use this one here, okay? And you want to look at those E naughts, okay? So, go back here. So these are the two equations. So we have zinc, 2+ plus 2 electrons, produce Zn, and the EV is 0.76 volts, okay? Then you have copper, 2+ plus 2 electrons, produces the copper solid, which is positive 0.34 volts. Now, the reason I just wrote the equations like this is we're going to make the following equation above. So we know this one is going to undergo oxidation, and this one's going to undergo reduction. So what we want to do is pretty much we want to rearrange the equation so it suits that, okay? So we're not going to flip this equation because this equation is saying it's gaining electrons. We want to flip the zinc equation because we want to write it like it's losing electrons, because at the moment it's saying it's gaining electrons. So what we're going to do is we're just going to flip the equation around. So I'll just rub out this thing if it works. There we go. So flip this guy around. So we have zinc gives you zinc. Oh, let's try it again. Zinc 2+ plus the 2 electrons. Now, if you're flipping the equation, you have to flip the voltage around, so 0.76 volts. Now, if you added the two equations together, the electrons will cancel out because you have 2 electrons on the left-hand side and 2 electrons on this side. So if you added the two equations together, you get zinc plus Cu2+ produces zinc 2+ plus copper. And then you would have that standard potential, which is going to be positive 1.1 volts. Okay, so straight away I've written the equation like this here, and that's given me the voltage, which has actually answered the question because it was calculate the cell potential for the galvanic cell under conditions. So the correct answer here is D. Okay, and that's how you would do that one. Okay, if it's written in this form here. Okay, so my advice when doing questions like this, find where they are sitting on that table, work out which one's undergoing oxidation, which one's undergoing reduction, and from there just try and make the equation and flip the voltages around if you flip the equations, and then add them together, and that won't fail you. Okay, guaranteed. Okay, alright, so let's take a look at this next one. So question 7. Now when I did this one, I actually got this one wrong because I read it wrong. Analyze the experiment data above to determine the relative strengths of acids strongest to weakest. So when I did this question, I did the other way around. I got the correct answers, but I had them the opposite way around, okay? So straight away, a low pH indicates a strong acid, okay? Now straight away, the strongest acid here is this, okay? Now they're saying determine the relative strengths from strongest to weakest. So the strongest acid is going to be this guy here. So straight away, it's between A and B. Now, I actually put it the other way around. I had one of these guys here, but I think I chose the bottom one, but that wasn't correct either. So we know for a fact it's not going to be C or D, okay, because they've got it in the opposite order, okay. Alright, so here now we got to work at the pecking order pretty much, okay. So straight away, the next strongest acid would obviously be H3PO4, okay, because it's got the next lowest pH, and we can see they have that same thing there, okay, so there's no difference. The difference is between these two guys, so whatever's more basic, okay. So here we can see clearly that the HCN has the highest pH, okay. So because that has the highest pH, that's automatically at the back. So we look for the one at the back, and it's that there, okay. Now concentration does play a little part in this, but if you look here between these two guys, there isn't much difference in the concentration, really. The only real difference in concentration is between the acids compared to everything else, but they're already so strong it doesn't make much of a difference. So they want you to look at the concentration, but mostly the pH in this case here. So the correct answer here is B. And the reason why we can make this judgment is because there's such a low difference in the concentrations, but there's such a big difference in the pH. That's why we can say this is more basic than this guy here. Okay? Obviously, if you increase concentrations, that might change things, but in this case here, that's what's happened. So the correct answer is B. Okay? Alrighty, question 8. This one was interesting to have a go at, and I actually had to Google like the reasons why this actually works, and I'll explain to you why this works, okay? So an organic compound X reacts with sodium hydrogenate carbonate to form carbon dioxide gas. The compound X is. Alright, so straight away, this one here, the amine, it can react, but it actually won't produce CO2, okay? This one won't react because it's a proton donor. So straight away, it's not these two, okay? This one can't really do it because it's not acidic enough, okay? To produce this stuff here. So it's not that one. So it has to be a carboxylic acid, okay? So pretty much this stuff here, out of these ones here, the most likely one is the carboxylic acid. And that's how you answer this one, okay? But that one is hard. If I did it fresh, without any research before, I probably would have got that one wrong, okay? But this one here, this one could do it, but it won't produce CO2. This one won't do it because it's a proton donor. This one is not acidic enough to produce the stuff here, okay? Alrighty, question 9. Oh, I can never pronounce this one. I'm not even going to pronounce that. Is formed in the following reaction, okay? So this chemical here. And we have an equilibrium system. So, which of the following is true about the system at equilibrium? Okay, so it's exothermic. So if it's exothermic, I want you to think of this equation like this. Plus heat. That always helps me, okay? So if you remove CO2, it'll increase the yield of phosphogene. So that's that chemical there. So if you remove this from the system, because it's equilibrium, it'll actually shift from right to left to produce more of this. So this is incorrect straight away, because that is not how equilibrium works, okay? Adding a catalyst will increase the yield. No, a catalyst won't do that. A catalyst will lower the activation energy. It won't produce more of this. It will just speed up the reaction, okay? So, not that either. Increasing the pressure will increase the yield. So if you increase the pressure, let's think. Well, actually, removing. Let's think. Removing CO2 will increase the yield of that. You'll shift to that side and keep that constant, so that's incorrect. Increasing the pressure. So if you increase the pressure, it'll shift to the side with the least number of molecules. So if you increase the pressure, it'll shift from left to right. So it will produce more of that. Yep. So that one's correct. D, decreasing the temperature will increase the yield. So if you decrease the temperature, you're taking energy out from here. So it will shift to that side. However, the equilibrium constant will change if you change the temperature. Okay? So it's not that one either. So I would say the correct answer is C. I'm not sure actually what the answer is with this one. I can't remember. I'll go back and check. If there's any updates to any answers, take a look in the comments and you'll be able to see if I made updates. But I'm going to say it's C, because if you increase the pressure, if you're increasing the pressure, you're decreasing the volume in which the system is in, okay? Which in turn, the equation will shift to the side with the least number of particles. There's 2 particles here and 1 particle here, so it'll shift to that side. And it'll keep the constant. The only reason why I'm saying D is incorrect is because I know temperature can change the Kc constant. So that's the only reason why I'm not saying that. It would, decreasing the temperature will decrease the, actually no, that one's also incorrect. Because if you decrease the temperature, you're taking energy from this side here. So it would actually shift from left to right to produce more of this, which is the opposite of what they're saying here. So the correct answer, I think, is C. Okay. But yeah, let's go to the next one. Alright, question 10. So, which of the following is true for the electrochemical cell? So here we have this. We have silver as the anode, Fork is the cathode. So anode is where oxidation occurs. Cathode is where reduction occurs. Okay. So straight away look for stuff like that. So I know for a fact it's going to be between A and D, because straight away they have anode as oxidation, oxidation. So here it is neither one of these guys here, because they've gone positive and negative. You refer to it as pretty much where it's oxidation and stuff. Now, it is going to be non-spontaneous, okay? Spontaneous means how fast it is. This will be non-spontaneous because stuff will move, okay? It's not going to act instantly straight away. Some of this, if it's undergoing oxidation, it's losing electrons, meaning some of the precipitant here will go into there. And if this is the cathode, where it's gaining electrons, it will form more precipitant here. So it's not going to be very spontaneous. It's going to take time pretty much. So I'm going to say the correct answer is D. Okay. Alrighty. Question 11. Now question 11 was another one that tricked me. But there's some tricks you can do with here. So determine the color of the solution with a pH of 9.6 containing bromo green indicator. So pretty much the way you got to think about pH is you've got to actually know a little bit about the rainbow, okay? So pH scale is 1 to 14, okay? Now, if you start the rainbow here, you have actually red here, and as it goes down, it gets more basic. So anything with a very red color is very acidic, okay? Now, because it's 9.6, that's going to be very close up this end. So straight away, I know for a fact it's not going to be pink or yellow, because that's going to be on this end, on the acidic end, because it's closer to red, which is closer to the lower numbers. Now, I said originally green, but the actual answer is blue. But if you actually learn some stuff a bit, so yellow is going to be the color if it's less than 3.8. Green is going to be between if it's 3.8 and 5.4. And it's going to be blue if it's greater than 5.4. Now in this case here it's greater than 5.4, so the color you're going to see is blue. But I actually didn't know that, but this is a good thing to know when you're doing stuff like this. Attaching pre-existing knowledge like the color of the rainbow to the pH scale is a very easy thing, I think, to remember. Okay? But anyway, let's head down to the next one. Alrighty. So, use IUPAC rules to name the molecule. So straight away, you've got to find the longest carbon chain. So we have 1, 2, 3, 4, 5. So it's 5 carbons. So straight away, you're going to be using the prefix pent. Okay? Now, you would use pentane if there's only single bonds, but because there's a double bond, you're going to use the back bit as En. So you've got P, I think it's pentene or something like that. So it's not going to be C or D. Now the reason why they might have put C or D is they might have said, or they might have thought that's not the longest carbon chain, and they might have broken up into 2 other things. So it's not going to be these 2 here. It's out of these guys. Now the main difference here is pretty much, is it cis or trans, okay? Now, cis and trans are, what's the word? I can never pronounce the word, but they're like very structurally different, okay? So the way you've got to think about cis and trans is, imagine you've had something like this. You have carbon, double bond, carbon, something here, let's go hydrogen, something here, hydrogen. You have chlorine and chlorine, okay? This is what we call cis, okay? Because they're on the same size like this. Trans looks like this, okay? Double bond, chlorine, chlorine, like this, okay? So that's trans, okay? So from this structure here, this here is cis, okay? So the correct answer is going to be cis, okay? Cis 2 pentane, okay? And the reason why it's 2 is because 1, 2, 3, 1, 2. So I'd assume that's the number where you're counting from. Okay. So the correct answer here is A. Okay. And that's the difference between cis and trans in chemistry. Okay. All right. Question 13. Identify the equivalence point on the titration curve. So the equivalence point is the steepest point here, where the pKa equals this bit here. So the point of equivalence, okay, is going to be that steepest point, okay? So the correct answer here would be D, okay? I think it's when pKa equals Kc or something like that. But yeah. Question 14. Ammonium gas reacts with oxygen gas in the following equation. The equilibrium expression for the reaction is. So, remember, Kc is your products over your reactants, okay? Now, you put the concentrations in little things like this. So you'll have N2, but you put the coefficients as power, so it'll be N2 squared, and then you'll have H2O6, okay? And then on the bottom you'll have O2 cubed, and then here you would have, that's ammonia, I think, yeah, 4. So you look for the one that looks like that, okay? So straight away the correct answer is going to be D. If you're not sure, it's going to be on your formula sheet up here, I believe. That's for acids, this one here. You want to use that. If it's an acidic solution, which this one isn't, you don't include water, you just write it like these guys here. But this is just a normal equilibrium system. Okay. Alright, question 15. This compound is an unsaturated fatty acid because it contains, so straight away, it contains a carboxylic acid and the double bond. That's why pretty much it's unsaturated and a fatty acid. Okay, so that one there. Pretty easy question. Alright, the reaction shows. Alright, so we've got this plus 2H2 and you're producing this stuff here. I can't remember the names of these guys here. You can probably work it out. So straight away, we've got addition, reduction, oxidation, substitution. So it's not substitution. Oxidation, nope, not that. So it's out of reduction and addition. Nitrile to amine. So reduction, we're looking about charges potentially. So this one here, now if you put that there, it's a reduction, I believe. Okay. Because I don't think it's an addition, because I don't think a double bond will be broken anywhere. Okay. And I think the reduction is more likely here. Okay. Because it's going from a nitrile to an amine, I think. Yeah, I'm pretty sure that is a nitrile. Yeah, that's a nitrile and that's an amine. So that matches perfectly. This one here is the opposite as well. It's saying it's going from an amine to a nitrile. That's not an amine. That's an amine. That's a nitrile. So straight away, it's B. Okay. Alrighty. So, which of the following represents a spontaneous redox reaction with the correct standard electric potential? Now, this one here is actually quite hard because it takes more than a couple minutes to work out. So, what we want to know is, alright, what does spontaneous mean in this case? Yes. Well, spontaneous means the largest E naught that's positive. So, straight away, most people are going to say A, but I'll tell you why it's not A. Okay? So, if you think about it with this one here, you've got sodium, whatever this is, bromine, I'm not sure the chemical names, and they give you this value here. Because look at the last bit, they said with the correct standard electric potential, okay? This actually isn't correct, okay? Because if you look at your formulas here, if we go down here, if you go to sodium, this one here, I'll highlight the other ones. So sodium and where is the other one? Br. Here we go. Oh, I lost it. There we go. So we have 1.08, this, and then we have 2.71. Okay. Now, what one's undergoing oxidation and reduction? If we look back on our thing, the sodium is gaining an electron. So it's undergoing reduction, okay? The bromine is going from a negative charge to a positive charge, so it's lost its negative charge. So it's undergoing oxidation, okay? So if we were to write the equation, we have Na plus electron produces Na, and we had negative 2.71. Then we had bromine 2, the 2, yep, so bromine 2, oh, why is the pen not working? That's not good, try again. So we have bromine 2, this is just straight off the book, plus 2 electrons produces 2 bromine negative, and the electro thing is positive 1.08. So if this is undergoing oxidation, so it's losing electrons, that means this charge actually has to be flipped the other way. Because look how it's set up in the equation. They've got this on the opposite side. So you actually have to flip this guy around. So you have 2Br negative producing Br2 plus the electrons. This will be negative 1.08. So if you add this guy and this guy, you're actually going to get this number here, but the negative version. So this here in the table is actually incorrect. So the correct answer is not A. Okay? Which leaves the next one with the biggest E0, which would be C, because of that thing there. So that's the most spontaneous reduction reaction. And I'm pretty sure if you check the E0, that is going to be correct as well. But yeah, that's how you answer this question. And a lot of people get this one wrong. But yeah. Alright, so question 18. A solution A has a pH of 3. A solution B has a pH of 6. Okay. This indicates the solution A, and then we have all this stuff here. So straight away, we want to be using this formula. So pH is negative log 10 of H plus. Okay. So pretty much, if we want to know what H plus is, that's going to be 10 negative pH. Okay. So we want to work out how much bigger of, well, difference between the two of them, because if you look at the general equation, they're talking about concentration of hydrogen ions. Okay. Now straight away we want, which one's more acidic, okay, and which one's less acidic? Well, the one with the lowest number here is the more acidic one, so A is more acidic than B. Okay, so indicate solution A is more acidic, so it could be out of B and D. So it's not C or A because they're saying less acidic. Now here we have 2 times and 1,000 times. Now people would say 2 times because 2 times 3 gives you 6. But that's not the case here. You need to compare the hydrogen ion concentration. So if we look at solution A, the hydrogen concentration will be 10 to the negative 3. If you look at solution B, the hydrogen ion concentration will be 10 to the negative 6. Now we can see, it's hard to tell, but this number is actually bigger than this one. So if we go this divided by that, that'll tell me how many times bigger A is than B. So if you go 10 to the negative 3 divided by 10 to the negative 6, that'll give you 10 to the 3, which is 1,000. So the correct answer is actually D. Okay, and that one's a bit tricky to do because you've got to do a little bit of mathematics here. The way you can find this formula, it's on your sheet, just up there. So just in there. Okay. Alrighty. Question 19. So, dispersion forces, hydrogen bonding, defuels, bridges, and ionic bondings all contribute to, straight away, is going to be the tertiary structure of proteins. Okay, so that's something you just have to learn pretty much. Okay, it's not going to be the rest of these guys here. Alright, question 20. This is where we need this diagram here. Okay, so it said pretty much this stimulus cannot be published, so you have to view it via this link here, which is what I searched up here, which is pretty much a galvanic cell. So straight away, if we look here, we've got copper solution. It's losing electrons and it's losing its precipitant here and turning into just a solution here. The silver is actually forming more precipitant here because the electrons are flowing over and they're reacting here and making more solid. Okay. So straight away, this one's losing electrons, so this is undergoing oxidation, hence it's the anode. This one's undergoing reduction, hence it's the cathode. Okay, so now we just go use that information to answer this multiple choice question. Determine which of the following statements is true for the electrolytic cell. Oxidation occurs on the surface of copper. Okay, so straight away that one's true. Okay, and there's usually only one true statement here. Now oxidation is occurring here because it's losing electrons, and that's the definition of oxidation. So I'm going to say straight away the answer is D, but we'll also show why these ones are wrong. So copper ions are reduced. That's not true, because that's contradicting this guy down here, so that's one's not true. Copper is the positive electrolytic cell. No, it's not. It's the anode, which is the negative. Electrons flow through the salt bridge. No, they don't. The spectator ions do. So straight away the answer is D. Alrighty, I hope you enjoyed this video. So this was the multiple choice for the Chemistry Paper 1 2020. If you have any questions at all with these ones, please leave me a message in the comments, because I haven't done chemistry in a bit, but I do think all these ones are correct. But yeah, if you like this video, like and subscribe, and I'll see you in the next video. See ya!